Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is AMIRAH ADAWIAH binti RAHIMI. So my group will present about quadrature in amplitude modulation. Okay, quadrature means 90 degrees between two waves of the same frequency as in the color difference signal of television screen. Okay, QAM means a combination of amplitude and phase changes to give additional capacity. So it provides high level of spectrum's usage efficiency. It also provides significant benefit for data transmission, and it used for analog data transmission including AM stereo transmission. It also a form of digital modulation method. So that's all from me.
Assalamualaikum and hi, my name is HAZWAN bin IDRUS and here I am to present about the methodology. So for the QAM expression, since QAM belongs to amARRI signaling and amARRI QAM can be defined by the following equation: ST equals to AM times GT times cos in bracket 2 pi FCT plus theta M, which is the ST stands for band pass signal, AM stands for amplitude of message signal, FC stands for carrier frequency, and theta M stands for phase angle of message signal, and GT stands for real value signal. Okay, so next for QAM block diagram, there is two port network, which is the first one is for input and the second one is for carrier. Which from the input we can see that it will go straight forward to the balance modulator, which will mix the audio signal and the radio frequency carrier, but suppresses the carrier, leaving only the sidebands. And then it will simply go to the phase shifter, will be phase shift to 90 degree, and then it will be sum up between the input and the carrier. Both of them will be sum up, and that's the output for the QAM. And then next you can see as the pictorial representation of QAM, you can see that there's a combination of the carrier and the input. So the output will be, the input will be phase shift, or simply it as an invert data. So how to generate QAM? In order to generate QAM, we need two modulating signals are derived by special pre-processing from the information bit stream. Then the two replicas of the carrier frequency sine waves are generated, in which one is delayed by 90 degrees. These two different modulating signals are used to modulate the two carriers. As a result, two modulator signals can be added together. The result is a sine wave having a constant frequency but having an amplitude and phase that both vary to convey the information. There are 6 forms of QAM, which is first 8 QAM, 16 QAM, 32 QAM, 164 QAM, 128 QAM, and 256 QAM. So as you can see in the diagram, there is a constellation diagrams of different forms of QAMs. There is a circular constellation which limit for 2 QAM only, which is for 8 QAM and 16 QAM for another QAM. So next I am going to present about the disadvantages of circular constellation, which is only limited to the 8 QAM and 60 QAM. So when the value of M increases, plotting the signal becomes complicated. The distance between the signal points increases, which results in complexity. As a result of these limitations, we are going for rectangular constellations. As you can see in the diagram, there is a constellation diagrams of different forms of QAM. As you can see, many from the 8 QAM until 256 QAM may be applied on the rectangular constellations. So what is the probability of error of QAM? The probability of error for a QAM signal is obtained from a pair of TAM signals, each indicating the in-phase and quadrature component. The probability of error of QAM is different for different forms of QAM. The probability of error for QAM is given by PB equals to 1/2 times ERFC in bracket EB over N naught close the bracket per 1/2, and the probability of error for 16 QAM is given by PB equals to 3/8 times ERFC in bracket 2EB over 5 N naught, and then divided and to the power of 1/2, and the probability of error for 64 QAM is given by PB equals to 7/24 times ERFC in bracket EB over 7 N naught to the power of 1/2. So there's a graph for performance characteristic of QAM.
Assalamualaikum, my name is NURSYAFIENAH and I'm going to explain about QAM modulator and demodulator. Okay, as you can see, this is the QAM IQ modulator circuit. The QAM modulator essentially follows the idea that can be seen from the basic QAM theory, where there are two carrier signals with a phase shift of 90 degrees between them. These are then amplitude modulated with the two data streams known as the I or in phase and the Q or quadrature data streams. The two resultant signals are summed and then processed as required in the RF signal chain, typically converting them in frequency to the required final frequency and amplifying them as required. Next is QAM IQ demodulator circuit. The QAM demodulator is very much the reverse of the QAM modulator. The signals enter the system, they are split and each side is applied to a mixer. One half has the in-phase local oscillator applied and the other half has the quadrature oscillator signal applied. That's all.
Hello and Assalamualaikum. My name is iLmam bin Awang Tajudin. Today I would like to presenting about advantage and disadvantage of quadrature amplitude modulation. Firstly is for the advantages. The first advantage of QAM is increase the efficiency of transmission for radio communication system. Second is QAM frequency efficiency is better than PSK, QPSK modulation method. Third is the receiver embodiment and recovery are relatively easy. The last is gain reducing and eliminating interface caused by continuous carrier near the modulation setband. For the disadvantages, the firstly is more susceptible to noise. Second is less efficient and consume more power. The third is require coherent demodulation with exact pace and frequency. The last is weak and sensitive to an error. Okay, conclusion for this QAM. QAM is an important modulation scheme with many practical applications, including current and future wireless technologies. Some of communication systems that use QAM such as Wi-Fi, cable modem, digital video broadcast, and WiMAX. Thank you.